Okay, folks, we're going to look at our last one in radial line, and this really is as complicated as it gets for a radial line at this point. And we're going to look at the same frustum that we just looked at. I've already drawn the elevation view. I've put a profile on. And we're going to now look at a frustum cut on a miter. So this would be like a roof jack or something like that. And it all starts off the exact same way as it did before. So let's carry this one on a little bit and finish the elevation view with all our element lines. So I'm going to draw this up, bring my profile heights vertical to the baseline. Then I'm going to bring those to the apex point. Apex point we refer to in an elevation view, but once we start looking at our pattern view, our apex point is no longer there. It becomes a radius point. So we don't have an apex in a pattern view of a cone. Okay, so we're almost finished our elevation view. We've got our frustum drawn, we've got it profiled, profiles brought vertical into the base, and then to the apex point. The part we're missing, the difference now, is we're going to put a miter. We're going to put a cut on a pitch or cut on an angle. But we have to think of that fitting as exactly the same starting point. And our limitations with a cone on a pitch using radial line is we cannot keep a round shape on the actual part now. The round shape is on the base, a horizontal base. So if we cut it, it's just like cutting a piece of pipe on a miter. It becomes elliptical. This is no different. We it's impossible to make a cone cut on a pitch with a round base, with a round bottom on the angle. It will always be based off of this. So even if you're given something, a drawing like this, you can't, if this wanted 6-inch diameter, say, from here to here, you cannot use radial line. It will not work, okay? It's not going to work. What will work is imagining this being a flat base. Now this can be 6-inch diameter. This is check mark. Yes, we can do it. We have to have that. So if you have ever a drawing, a shop drawing, and you have the base is cut on an angle, and that's where the dimension is, right there, you can't use radial line. Okay, you have to move on. Radial line has to be based off of the flat bottom. Okay, so that's why we draw it. And I always recommend draw the whole fitting out like this before you even put the miter line on. There's no changes to the way that you draw it, so don't even bother. Just start out with the cone. Okay, now we can come in and put our miter in there, and let's go, I don't know, 15 degrees. Something like that. Okay, what the common mistakes are when we have a fit in like this is coming from our point here straight up to the apex. We can't do that. Okay, we can't do that. It's going to change all the element lines. They're not going to be proper. This is showing us depth. The other common mistake is bringing these vertical until the miter line, and that is not correct either. You can see this one wouldn't even be in the cone anymore. It would fall right off. That's an indicator that you're doing it wrong. Okay? They go vertical to the base, then to the apex where it crosses the miter line. That's where it crosses. Okay? So let's put some numbers on this one, because this one we really want to follow our numbers. It's really the only radial line that we have to. Or you may want to put that in there because it's the only one where we actually have to draw in all our step-offs and draw in all the element lines on our part. Besides the pyramid, we needed it on the pyramid. So now we look at the cone, and let's talk about a couple of things on here. We know the slant height is the blue, the outside edge. That's our true length. We're going to swing that arc. We've done that. Okay. But now we see that the element lines are different along the miter line. So that slant height's not going to work for us in all the spots. Okay. But what we want to try and imagine on this one, and let's imagine this is cut on a miter here. Okay, and if we look at the two of them together, if I start rotating this cone, and imagine this one's being rotated, imagine I'm going to bring this corner and rotate it all the way around. Even if I drew a line on here, I'm bringing that around. None of these heights change as I rotate it. Okay, those heights remain consistent. So on center, it hits at this elevation, and it stays at that elevation no matter where I rotate the cone. So if I put a point on there like that, as I rotate it, even when it's on the outside edge, it's still, the height this way is consistent. It rotates along a horizontal plane. Okay, that's really important as far as the concepts of what we're doing here. And what we're going to do is rotate this cone, projecting all the element lines that hit the miter line to the outside edge. Okay, so again, think of us rotating. And if I rotate that cone, I rotate it, the elevation here doesn't change, but look at the length of the line now. It went from this distance here, and now it's from here to here. It got longer. As we rotated it to the outside edge, it became a true length. Because remember, it's coming out at us, it's got depth to us, but then as we rotate that, let me use my ruler, okay, it's like this, and it's somewhere in here. As I rotate it, the line gets longer. The height here isn't changing, my pen's at the same spot. It gets rotated around. Okay, so if we project them all horizontally to the outside edge, they all become true lengths. And that's the key difference here. Out, out. Okay, we got all our lines out there now. So now I'm going to move this 7 just down a little bit. We have 1 here. That projected across on the base because it's right down at the bottom. So 1 comes here. 2 comes up, hits, comes across. So there's 2. 3, 3, 4. Okay? So you follow your lines and you'll see all those. That's going to give us 7 is here, but it's actually 7 up here. 6, 5, 4, 3, 2, and 1. Okay, 7 is located in this lower corner here, but then remember there's nothing there until up here. And 1 is this corner, and let's rotate it around, and it becomes that one there. Okay, 1, 2, 3, 4, 5, 6, 7. So now it's the same process. We pick up our slant height, but we have 7 or 8 of them now, including the frustum. We have our 8th. So we got to swing a lot more arcs. And that's really the only difference. If we think of the main components, we're going to pick up the slant height, swing that arc, make the distance of that arc equal to the base circumference. So let's pick a radius spot, maybe here. And I always start with my large one, but it's up to you. I just find that encompasses as big as anything's going to get, so why not start there? So then I know it's not going to get any bigger. Okay, so there's all our arcs we need. Let's give ourselves a starting point. There. Okay, now I'm going to establish the length of the lower arc, or the outside arc, with my step off. This one again is important. Pick a step off, doesn't matter, they're all equal. They should be equal, you can always check them. Looks pretty good. It has to go off your large arc. Okay, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Again, you could check it. You could profile your top and bring that through. But now each of these lines has to come back to the radius point. Remember, it's a radius point, not an apex. Apex is the elevation view. Okay, so we start to see in our shape here. We have our pattern. Okay, this is going to be our pattern inside here. And let's follow some numbering so that we can follow our lines here. Now we want to choose where we want to put our seam on, and normally that we just choose that by shortest side. And my shortest side is here, that's at 0.7. So I'm going to start at 0.7, and then I follow the number line. All the way around. And end at the same spot we started. That will join and become 1. So now 7, we're back to circling our points. Remember, don't fog them out, circle it. And then 6 was my next one down, and over 1, down 1. 4, 3, 2, 1 is our outside, the very longest arc, and then back up, over 1, up 1. And end at the shortest one again. Use your flexible curve and draw that in. I won't even bother trying to freehand it because I won't get anything nice, but there's our pattern there now, is in here. Cut out the rest, all scrap. Keep the pattern inside. Going on a pitch, using radial line.